So welcome back to this series of videos where we are looking at momentum of an object. We have just seen that momentum of an object is a product of its mass and its velocity. We have also seen that momentum is a vector. A vector is a physical quantity with both direction and magnitude. And the direction of the momentum is the same as the direction of the velocity. So if you know the direction of the velocity of an object, which by the way is a vector by itself, but mass is a scalar, if you know the direction of the velocity, you should know the direction of the momentum. We have seen that the units of momentum is equal to the units of mass times the units of velocity, which will give us kilograms meter per second. Those are the kind of things that we've seen. Now, if I want to calculate the momentum of this object, then it will be its mass, which is 1500 kilograms, times its velocity, which is 20 meter per second. And this one will give me 30,000 kilograms meter per second to the right. 30,000 kilograms meter per second to the right. Now this one is a small van. Suppose it were to move with double this velocity. So its velocity was initially 20 meters per second. This was the initial velocity. Suppose its final velocity after maybe the engine exerts a certain amount of force is 40 meters per second. So this will be the initial momentum of that van. After its velocity becomes 40 meters per second, then its momentum will be, of course, its mass is 1500 times 40 meters per second. This will give us 60,000 kilograms meter per second. So you can see that when you double the velocity of the object, its momentum doubles too. So velocity is one of the factors which affects momentum of an object. So you can increase the momentum of an object by varying its velocity. Velocity is a factor which affects momentum. So momentum depends on these two factors, the mass of the object and its velocity. So velocity is an independent variable, while momentum is a dependent variable. It is a variable which depends on these two. Now, it may not be very easy to change the momentum of an object using its mass, because in most cases the mass of the object may be fixed. But for this van here, we can change its mass by maybe adding some more luggage onto it, or if it was carrying some luggage, we can remove some of that luggage. And we'll be able to see that way we can be able to vary its mass. But in most cases, you'll find that the mass of the object or the mass of the particle will always be fixed. So the easiest variable to change is its velocity. So I hope from this, you've been able to learn one or two things, and the facts which I want you to remember here are these. Momentum is given by this equation. It is a vector, and its direction is the same as the direction of its velocity. Momentum depends on these two variables. It is a dependent variable, while these two are the independent variables. In other words, when we say that, momentum depends on these two. It will not be right to say that velocity depends on the momentum. It would not be right to say that. So don't reverse them. Notice that here we are talking about momentum being dependent on the mass and its velocity. We are not saying that the mass of the object depends on momentum. It will be illogical to say that. It will be like saying if we change the momentum of the object, the mass is going to change. That one does not make much sense. So when we talk about factors which affect a certain given quantity, the reverse is usually not applicable. And here I'm using this particular aspect here, that it is not possible to change the mass of the object by changing its momentum, but it is possible to change the momentum of the object by changing its mass. In that case, we say that momentum depends on the mass of the object. It is not the other way around. We do not say that the mass of the object depends on its momentum. I hope you're getting this, because there are certain things which obviously cannot change. We cannot change the mass of the object by changing its momentum, but we can change the momentum of the object by changing its mass. The other thing is, just the way we outline our work. At this particular moment, at this particular point, I just want to emphasize a few points. Like, for instance, the way you arrange your work. Notice the way I've put my equal signs. The first thing I do is to write the equation. And then the next thing is the substitution into that equation. You've got the option of either including the units when you are substituting. If it's a very simple equation, you can do that. But when the equation becomes too complicated, don't bother with the units, with substituting into the equation with the units. Don't do that unless your intention is to derive the units of that physical quantity which you are calculating. Don't do that, because it can make your calculation to be very complicated. We have also reviewed the factors which affect momentum of an object. At this particular point, I'd like to compare this small van with a truck of 20 tons of mass, 20 tons. That means 20,000 kilograms. So, what would be the velocity of such a truck if we want its momentum to be the same as the momentum of this small van? Maybe you can pause the video and calculate that. It is a good challenge when you're thinking about another van, another vehicle with a different mass, but you want the two vehicles to have the same momentum. The truck has a mass of 20,000 kilograms. The small van has a mass of 1,500 kilograms. The small van is moving with a velocity of 20 meters per second. With what velocity must the truck move so that its momentum is the same as the momentum of the small van? Solve that. It can give you some practice into the use of this equation. In the next video, we are going to look at a situation whereby we've got different particles or different objects which are moving with different velocities. They may have the same mass, they may have different masses, and then we're going to see how we calculate the total momentum of that particular system. And when we talk about total momentum, we are talking about resultant momentum, because when we add two or more vector quantities, we always get the resultant. So in the next video, we are going to see how we get resultant momentum of a system.